let's get started. Thank you very much for coming to this this session about decision making. And let me introduce myself. My name is Donald Farmer, and I work on the business intelligence management team at Microsoft, which is a very fancy way of saying that I don't have a real job description. I just work on sort of coordinating different aspects of what we do in business intelligence. In particular, I try and work with key customers, key partners, and analysts in the industry and internal teams at Microsoft to ensure that we're telling a consistent story about how BI works and about how BI can improve the operations of businesses that we're working with. It's a very interesting role for me. I've been doing it for some time. I've been at Microsoft for about 10 years. I've been in BI world for much longer than that. I've been working in BI for about probably 17 years in total, if I was to look at my resume closely. And I've been in the BI world for long enough that I can remember when we didn't talk about business intelligence. We talked instead about decision support. And I much prefer the name decision support because that's what BI was before marketing got hold of it. It tells you exactly what the software does. It supports you in making decisions. It gives you the right information at the right time and the right place to make the right decisions or to make better decisions. So I prefer that name, and thus the title of today's sessions, Decisions, Decisions, Decisions. It's about the decision-making process in a business and how BI can help with that. Now, there's a few things I'm going to do. I'm going to talk a lot about the decision-making process. I'm going to show you some demos, of course, of Microsoft technologies that fit in there, and we'll talk a little bit about the future of some of those technologies. And we're going to set the scene for hopefully a lot of the sessions that you'll be attending over the course of the conference about business intelligence and data technologies. Now, I always go back to this point that business intelligence, we can talk about it as decision support, but it's really all about data. It starts with data as being the center of our universe, if you like. And if we want to talk about data, I think we need to start where data lives. And in data, in the most modern of businesses, typically lives in the centralized data center. So let's start there. This, of course, is a data center. And it has all the usual concerns of a data center. It is, for example, concerned with storage. There's a lot of data in here. It's concerned with ease of access. These drawers are very carefully lubricated. And, in fact, it's also concerned with security. The little sign there, you can't quite read it at the high contrast monitor, but a little sign says confidential. So they take security very seriously in this data center. And in fact, the IT department who are managing this data center have all the usual concerns of IT departments. They're concerned with the storage and security of the data. They're concerned with the long-term life cycle of the data. They're concerned with security and so on. Backup may be a problem for them more than for you, but nevertheless, it's still a data center in that sense. And just to keep with this up-to-the-minute theme, we need to think about the other things that the IT teams do. IT teams, in addition to providing you with secure and data storage, they're also concerned with the quality of data and making sure that data is fit for purpose. Now, I wish I could give you a good definition of data quality, but I only have one, and that is the data fit for purpose? And the reason I can't give you a better one than that is because there is no one definition of good quality data in the enterprise. Good quality data is defined only by is it good for purpose. I can give you an example of this from a customer of mine who built a data warehouse to manage the credit card transactions of most of the stores in Europe who issue their own credit cards. They nearly all go through one particular broker. And in order to be able to analyze sales and transactions and credit across all stores, not just across one store, but across all the different stores using this system, they built a data warehouse. And very effective it was too. Now, in order to get this right, I'm sorry, I've got a sore throat, so I'm going to be drinking quite a lot of water. In order to get this right, they had to get rid of all the duplicate swipes. You go in and you try one card and that doesn't quite work, so you pull out another one and it doesn't quite work, and you pull out another one and it doesn't quite work. I'm not seeing anybody nodding in recognition, so it may just be my problem. But anyway, they cleaned up all this data, and now the sales analysts had a very clear view of who was buying what across which stores. which was absolutely great. They ran this system, and people got to hear about it, had good reputation within the enterprise. And then the fraud analysis guys came along and said, we'd love to use your data warehouse. And what we'd really like to do is analyze duplicate swipes, because they're a clear indicator of fraud. At which point, the data warehouse guy said, right, yes, all that's been archived and put in tape and locked away in Iron Mountain, and we can't get it for years. And so the data that was of good quality for sales analysis was of precisely useless quality for fraud analysis. And so the only definition I can give you of data quality is it fit for purpose? And one of the purposes of the IT team is, of course, to drive good quality data. That means understanding the business requirements and implementing the processes and validations required. And only IT can typically do it at the scale and the level of complexity that is required to ensure good quality data across the enterprise. So, IT, they secure and store your data, they ensure the quality and the validity of their data, they're stewards of the data. If you have business intelligence, if you have data warehouses, IT do something else. They also drive what we call that single version of the truth, the central version of the calculations that drive your business. Your financial reports, your management reports, the quarterly reports, the production reports, the annual report at the end of the year is all driven by a set of calculations that's executed by IT, typically on back-end systems such as OLAP. So IT, in addition to security and storage, and in addition to validation, they also drive that central set of calculations that drive your business. And they do this very effectively, at least I hope you do it very effectively. However, there is another world, and it's a very different world from the world of the corporate data center. It's a very different world from the world of organized data and validated data, and it's a very different world from one team driving a unified set of calculations across the entire enterprise. And that different world is the world of the desktop, which is considerably messier, considerably less organized, and considerably less well structured than the IT department. But here's this thing. We're talking about decision support, and virtually every decision in your enterprise is made in that environment, not in the highly organized IT environment. This is where decisions are made in every business on the desktop. And there's a reason why the desktop world is so messy and disorganized, which is because they're pulling in data from sources which IT don't even have control of. So, for example, in the world of Microsoft, we may do an acquisition. And don't rush for the stock exchange or anything. I'm not going to give anything away. But we may be planning on doing an acquisition. And if we were, we'd be looking at our sales numbers, for example, SQL Server Enterprise for the last 5 years. And we're a big company, so that's thousands of sales, tens of thousands of sales, hundreds of thousands of sales. So we're going to the data warehouse, we're pulling in those sales numbers, and we're looking for the trends. And we're looking at our CRM system and looking at the patterns of customers. But we're also looking at other things, which IT have no control over. We're looking, for example, at the accountants of the companies we may be interested in buying. We're looking at the trends of server sales for multi-core servers as predicted by Gartner and Forrester for the next 5 years. And I don't find that in the data warehouse. I find that in a PDF file on the analyst's website. And I find it on page 3, and it's 6 lines in a little table. And I can't go to the IT department and say, guys, can you take those 6 lines out of a PDF file and put them in the data warehouse so I can analyze it? And they're going to say, no, of course not. That's not what your data warehouse is for. So the world of the desktop analyst, where decisions are made, if those decisions are going to be data-driven, it includes data which is not in the IT world's domain. And that's not because IT hasn't got to it yet. It's because IT will never have that data and probably never should have that data, or at least never have that data to manage. So there's these different worlds of the desktop and the IT environment. And this is not a new problem. I don't want people to think that this is somehow, it's a new problem. I also don't want people to think that there's a technological solution to this, because it's actually part of the nature of the system. So again, in my theme of trying to keep you up with the latest developments, let me look at this white paper, which was published in 1914, the Library of Business Practice and Accounting and Office Methods. And it describes this problem, and very accurately. It says here that every executive has an endless chain of demands upon him for questions and answers. Now, that seems pretty straightforward. That's the only thing that dates that is the fact that it says him, the executive has to be him. But otherwise, it's actually pretty straightforward. And it also says that such demands consume a large percentage of the desk time unless the desk itself is made a means of answering the questions. Now, what They're talking about wooden desk. We're talking about desktop. But nevertheless, same problem. Unless your desktop is organized in such a way that you can answer these questions, then you're not going to be able to deal with all the issues that come up. And it says really interesting things here. The kind of issues they're talking about is, people looking for the returns on advertisements, people looking for, customers continually asking for this and that. And then it goes on to describe the answer to it. It says that the desk has become the center of a highly organized finding system. It's essentially a desktop search circa 1914. And, it only took us 106 years to get to, the 96 years to get to the next version of it. Hopefully version 2 comes along a bit quicker than that. But it's kind of interesting that they have essentially the same problems. How do I get my data onto the desktop where decisions are made? And how do I organize that, considering that the data comes from all these different places? There is structured data. There is semi-structured data involved in this process. So one of the things we have to think about then when we look at this messy world of the desktop is what kind of decisions are made, where are they made, and what data is required to support them. Sorry about that. Okay, so I like to think of decision-making as falling into a kind of spectrum of decisions. And it's kind of pretty straightforward to think of how this works. There is, for example, a very small number of very strategic decisions which are made in your business. Now, these are decisions such as which company are we going to buy, which new market are we going to enter. These days, sadly, things like which factory will we close or something like that. Strategic decisions, not made very often, very small number of them, but they really change the direction of your business when they're made. And then there's a far end, there's another set of decisions which are made at operational level. For the salesperson, which customer am I going to call on? For the operator working in a call center, it's how do I respond to this specific call. For the person working in manufacturing, it'll be what do I do about this particular alarm or notification that I received. These sort of things, they're operational decisions. There are many of them. In fact, in aggregate, they are your business, but each one of them is not highly strategic. Now, business intelligence didn't traditionally deal with strategic and operational decisions. It's traditionally dealt with tactical decisions, which sat right in the middle. Tactical decisions were typically made by middle managers and by analysts. They were informed by operational data, and the results of that analysis were then fed up to strategic decision makers, pushed up the pipeline for strategic decision makers to make decisions with. The strategic decision makers didn't get the operational data. The operational decision makers didn't see strategic data. It was the tactical decision makers in the middle who did that analysis and who also shared the results of that. So that world is generally true today for most companies I talk to. Very occasionally I'll speak to a customer. I spoke to a customer from China who told me that, well, actually, we don't have tactical and operational decisions. We just have strategy. And everybody performs in strategy. And occasionally I'll hear people who say things, well, we don't really have, well, a lot of people tell me the companies don't have strategic decision making, but they tend to mean it, more descriptively than prescriptively. But the interesting thing about this chart is that it's pretty much normal for most companies. Now, at the strategic level, decisions are made typically using dashboards and scorecards and written reports, that sort of thing. There's a couple of things which are important about these. The first thing is that they're easy to use, that they have to be easy to use. And this is not because your strategic decision makers aren't smart and can't understand anything more complex. It's because software is not their job. They are employed to be great leaders of the banking industry and to be great leaders of the cell phone industry and to be great leaders of the manufacturing industry or whatever else they're doing. They are not, first of all, they don't have time to take 3 days off and go and learn the latest analytics software. Oh yeah, let's go and learn Excel 2010. Your CEO is not going to go on a 2-day training course to learn the latest features. They just don't have that time. First of all, and that's not the skills that they have. Their skills are in their verticals, not in the sort of general analysis. Something very similar happens at the operational end. Salespeople, manufacturing engineers, and so on, they don't have necessarily core software skills. They're certainly not employed to have them. They're employed to be great salespeople or great teachers or great manufacturers and engineers. So they don't have those core skills, and they may not be able to take the time to spend 2-3 days learning the latest analytics software. It's actually in the middle where people are digging really deep into reporting and analytics that people have time and who get the return on the investment for doing and learning deep analytics. So we have to think of it in those terms. Simple, easy-to-use software at the dashboard and scorecard level, and in the middle, this is where people can actually drill into the analytics, and this is why traditionally BI has lived in that space. We have a strategy of moving business intelligence out into the dashboard and scorecard realm and into the operational realm, and in the operational realm is typically about reports. And it's typically about embedded reports, reports which are actually there right in front of the salesperson or right in front of the call center operator when they're speaking to a particular customer. If they have to boot up an analytic application in order to find the background of that customer, then they won't do it. They just don't have the time or effort to do that. If it's embedded right in front of them in the application they're currently using, then they will use that. And that's why all our BI applications, our OLAP, our reporting, our data mining, is embeddable inside other applications. The next thing to think about this is the data. Remember, I said the business intelligence is not just about decisions, it's all about data. The data flows through the business in different ways, but primarily it flows from operational through tactical up to strategic. Now, something very important happens at the operational level, which is we typically use something like integration services because the operational data is very fine-grained. It's every transaction. It's every customer interaction. And those are captured in typically very large ERP systems or very large operational systems. So you have to have a process for aggregating that data up, collecting it, conforming it across different systems. SQL Server Integration Services is our typical application for doing that. But at the next level, at the tactical level, you apply analytics to it, which is where we bring analysis services. Now, analysis services, when I first started working in OLAP way back in the kind of mid-90s, we primarily thought of OLAP as an accelerator for reports. It was a way of getting reports faster, of doing the calculations faster, because the results were all pre-aggregated into the cube. So you queried the cube, and you didn't have to go back to the original source in order to get fast results. But this was true, and this was useful, but it wasn't the full story, because today OLAP is primarily used not just as an accelerator, but as a way of enriching the model, enabling you to have a calculation which can be very complex, but which can be applied at any level of a fairly complex hierarchy. So you don't have to answer every question with a new calculation, either in terms of the execution of that calculation or the design of that calculation. You can design one set of calculations which go across the business in complex ways. The example I tend to give of this is what I call the Scottish Starbucks problem. And this is probably only the country where this might actually make sense. When I moved from Scotland to America in 2000, Scotland was a country of 4 million people, 5 million sheep, and 4 Starbucks. And I say you're probably the only country that can actually outdo that. But then I moved to America. I moved to a town called Woodinville, which is just outside Redmond, where the Microsoft campus is, which has not got 4 million people, 5 million sheep, and 4 Starbucks. It has 20,000 people, 20 sheep, and 6 Starbucks. And this is kind of interesting from a data intelligence. There's actually one corner. You can stand on one corner of Woodinville, just outside the cinema, and you can see 4 Starbucks from one corner. But the interesting thing about this is if you were going to do calculations, if you're driving the Starbucks data model, and you're thinking of comparing like for like, or you're thinking about comparing things like the efficiency of managers or the efficiency of store operations, the way your business is organized, I've got one town of 20,000 people which has got 6 Starbucks, and I've got a country with 4 Starbucks. The calculations which drive the measures of efficiency, the KPIs of performance, they're at completely different levels, but they're actually dealing with roughly the same number of drinks and customers and store managers and staff and so on. So how do I have a calculation which is going to be consistent at all those levels? Analysis services enables you to drive one calculation and then have it work at any level of the hierarchy, even though all the other parts of that change. It allows you to drive not just what we call one single version of the truth, but actually one version of the calculation, which enables you to do that consistency. So at this level, this tactical level, you're not just improving the performance by aggregation, you're actually building a business model which is consistent across your entire enterprise. So it's much more than just analysis. It's about modeling and the way in which your business talks to itself. The next step to think about then is the dashboard. What are our tools for dashboarding? And for dashboarding, our tools are straightforward. It's performance point services which drive dashboarding at that level. There's some other stuff that can happen here across this entire process. And one thing that we can look at is how do we build decisions into this, not just as a question of how does the data flow, but how does the decision actually made? Are there decisions we can make at the strategic level? Yes, they'll be made by managers, senior managers sitting down and issuing strategy documents or issuing their plans for the coming year. Decisions made at the tactical level are typically made with people who are, again, issuing instructions to others in order to execute against the strategy and against the tactics. But decisions made at the operational level are much more complex. Operational decisions with their embedded reports, tactical decisions with their cubes, and strategic decisions are all typically manual. And one of the questions you have to ask is there a way in which we can automate them? So I can expose decisions which are operational. I can expose decisions which are tactical and strategic. But I have to think of some things which I often call hidden decisions. Now, a hidden decision may be a little difficult to explain, but let me think of it this way. If I do not make a decision on something, I've actually decided not to decide. That sounds very inverse. So let me just give you an example of that. And it's a very simple one. Would we say something like this? We decided to treat every customer the same, regardless of demographics. That's our company policy. No matter who you are, we're going to market to you exactly the same, whether you're 16 or 60. Whether you're an 85-year-old pensioner or you're a 17-year-old teenager, we're going to sell mountain bikes to you in exactly the same way. And that would be a crazy strategy. But if you do not have a policy of customer segmentation, if you do not use analytic marketing to segment your customers and target to them differently, that's the decision you've made. You've made a non-decision, but it's turned out to be, if you invert it, it turns out to be a decision. Similarly, think of this one. We decided to treat every order the same regardless of profitability. Well, most of us prioritize our more profitable orders, or we attempt to do that. If you don't do that, then this is a decision you're making. You're deciding not to do it. What I find very useful for people who are looking at decision management is actually to think in these terms, to look at some of the non-decisions, invert them, and then think, is this sensible? If I made that decision, would it be a sensible decision to make? And then attempt to get decision management into the process to deal with this scenario. Now, one of the ways in which we can do this decision management is to use something like data mining. Data mining can actually do customer segmentation. But one thing you can do with the SQL Server world is you can actually use it for some automated decision processing. So I'm just going to flip over to a demo just now and show you. Is this showing okay? Yeah, show you some data mining in action. And I'm going to use it as part of a decision-making process. Now, the first thing I have here is this is just the data mining structure, which is connected back to a back-end SQL system. Here I have some data mining models. Now, the data mining models I have are basically 5 different models. I have a decision model, a naive Bayes model, neural net, logistic regression. You don't need to worry too much about those individual models. But the one on the right-hand side is called the champion model. We use very commonly within Microsoft itself when we do data mining, and we do a lot of data mining. Well, I've got to be careful about that. We do predictive analytics. Sometimes people don't like the word data mining because it sounds like something like the CIA would do or something like that. It sounds very kind of suspicious. So I always say predictive analytics. It's a much friendlier term. I was on a flight to Japan once. I was sitting next to this very nice lady, and she asked me what I did at Microsoft, and I said, I work on the data mining team. And she said, Microsoft does data mining? That's terrible. Should have said predictive analytics. I'd have been okay. But anyway, so these are the data mining models we have, but 5 of them. And the interesting one at the end is the one we call the champion model. So what we do in Microsoft is we typically build 4 or 5 models. Maybe we build more than this. We could build dozens of them, all with slightly different characteristics. And if I look at something like the mining accuracy chart, it enables us to judge which models are the best. In other words, statistically, which models are the best at giving predictions. So, for example, which models are the best at predicting who owns a home in this case? Because I have data coming from customers, and I want to know who are homeowners. Because I've got products I want to sell them that are appropriate for homeowners, but maybe not appropriate for somebody who's renting. So I can look at what we call the lift chart, which will draw me a chart of all the different models. And the chart has 2 straight lines. It has a random guess here, the random guess model. Now, the random guess model is about right. It's going to be a straight line because basically I could toss a coin and be 50% right. Somebody either is a homeowner or they aren't, so it's kind of binary. So on a random guess, I could just toss the coin, and those are the results I would get. There's then the perfect model, and the ideal model says basically that, I will get, if 56% of the population are homeowners, then I will find 56% of them using this model. And that is the perfect model. And you'll notice that all these squiggly lines in between, these are my models that I built. And fortunately, they're all better than random. And fortunately, they're all not quite as good as ideal. But I get a clear sense that, for example, neural net is the best model just now. Now, maybe next week or maybe next month, when the data has been processed again and I've got new data coming in from new customers, maybe neural net will no longer be the best because the data characteristics are such that decision trees are better. I could discover that, and all I have to do is rename decision tree to be the champion model, and now it will be the champion model in that case. So I continuously run what we call the champion challenger process on this in order to find whatever is the best mining model at any one time. And when I found that, how do I use it? Well, one of the ways I like to use it is in integration services. So here is an integration services package, and I'll just zoom in and show you the different parts of it. I have some data coming from a source. And the first thing I look at here is the house owner flag null or not? If the house owner flag is null, then I do not know if the house owner is a house owner or not. You've got to remember that binary values actually have 3 values. Yes, no, and don't know. Null doesn't mean, if your system, within your systems, if null means no, then you're wrong. Null means I don't know, I don't have that information. So if the house owner flag is null, I'm going to do a couple of things. On the left-hand side, then I have data, and that's okay. I'm just going to put a little flag in there, and a little flag will just say, we have this data. On the right-hand side, if the homeowner is null, I'm going to put it into a data mining query. That data mining query is going to call the data mining engine. So let me just look at the data mining query and show you what we've got. The data mining query is using the neural net just now. And the query, don't need to worry about all this stuff because I can build a query. The query builder basically says, join the neural net model to the input data and use it to identify homeowners and also get me a probability value that that is correct. So once I've got that, I have got, is this person a homeowner or not? And what is the probability that that prediction is correct? I can then do a conditional split based upon the probability and say if the probability is greater than 70%, then we'll use that for our marketing. If it's less than that, then in fact what we do is we send it down here and we send it for review and we say, well, it's low probability, let's not use it. And we should just put that in a text file somewhere and somebody else can use it. If it's high probability, then what I do here is I add a little flag to say it's inferred. So I always know whether I'm using real data or data that data mining has guessed. And then I can just pass it on to a union all to join all the data together, and I can push it off to the decision-making engine, which will, for example, send marketing material to all the people who I think are homeowners. So when I run this, let me just add a data viewer here. Add one at this point. Grid. Take these out. Let's do last name and take these 3. So now I'll find out their name, are they a homeowner, and what's the probability of that. I'll execute the package. And you'll see at this point just the data flowing through. We're going to pull about 20,000, 19,000 rows in from the source. And now I have, are these people, using the data visualizers here, I can see who is the person, are they a homeowner or not? Do we guess that they're a homeowner or not? And if so, what's the probability that that is correct? And all of these probabilities should be over 70%. So effectively what I'm doing here is I'm building an automated decision-making process which allows me, at this point, I only had 16,680 customers who I knew were homeowners. Now I have 1,424 that I can add to that I've got an inferred system for. So I've managed to make my data more complete and automate that decision-making process that previously we either would have thrown those customers away or we'd have had to go through and manually review 1,400 customers. So what I've done here is basically built an automated decision-making process, or at least the first part of an automated decision-making process to take us through that system. That doesn't look right, does it? Let's try that one. There we go. Okay. Getting a bit worried there, but there we go. So that was a little bit about business intelligence and decision making. I think the next thing we need to worry about is business intelligence and data governance. So business intelligence is a way of supporting and even making decisions is one thing, but how do I ensure that the data is correct? And very importantly, how do I understand what business users are doing with it at the end? I often compare this to a pharmacy. I can build all the controls into my system to ensure that you get the sleeping tablets that I intend for you, that you get the ones that the doctor prescribed, and that only you pick them up. What I can't ensure is that you don't take them home and immediately give them to your kids. At some point, I can put all the governance controls I need around the system, but at some point, I've got to trust you. And, that causes problems, because whenever I talk to IT departments about business users and business users about their IT departments, what I hear is that, well, let's illustrate it, they tend to face off against each other. It's not business users and IT, it's business users against IT. Now, business users have a very, very clear picture of IT departments. IT departments have one simple responsibility. They are there to support business users in what they do. Now, from that point of view, I've got to tell you that supporting business users can be pretty uncomfortable. They can be pretty unreasonable people at times. On the other hand, if you're a business user, being supported by IT can also be pretty uncomfortable. The result is often, frankly, open conflict between business users and IT. Certain lack of trust. You can never turn your back on the business user. You never know what they're going to do to you. Frankly, sometimes you don't want to know what's happening between business and IT, but there are possible solutions involving technology. But if you haven't bridged the gap between business and IT, you just have a bigger conflict. I've seen people say, well, that's okay, we'll just staff up the IT department more. But if you haven't bridged that gap, that conflict between business and user and IT, you haven't really solved anything. You could, of course, throw people and technology at the problem, but I can pretty much guarantee that that's only going to result in more chaos. The problem is that business users and IT departments often see data governance from different points of view. One side sees data governance as being about making the right decisions. Another sees data governance as being about compliance and ensuring that data is complete and accurate and up to date and so on. And these two views are not necessarily contradictory, but they do have some problems. Again, I like to think about it as being along a spectrum of actions that we do that have IT oversight, that is to see where IT are managing the action, where IT can understand what's actually happening. And then the other axis is organizational alignment. And what I mean by that is how well do these actions that we take, these analytic or decision-making actions, how well do they align with organizational goals and strategies? And you would think that these two are the same, but they're not. And the fact that they're not the same is the result of the IT, or the cause, if you like, of the IT and business user conflict. The most aligned view that I can think of about this is something like data warehousing and reporting. A data warehouse is a big investment. It's a big investment of IT time. It's also a big business investment. You're going to invest potentially millions of dollars in hardware and software and consultancy and time building a data warehouse. It better be aligned with your organizational needs. Doesn't necessarily mean it always is, but it really needs to be. And to be successful, it really needs an executive sponsor, not just within IT. You don't just want your CTO saying you want a data warehouse. You want your CFO saying we need a data warehouse if you're going to be successful with it. The other area, however, is things like the world of spreadsheets and the desktop. And that is where decisions are made often, as I say, in that messy desktop world. And that's also the area where IT have least control. I have some horror stories. I'm continually collecting horror stories about some of the things that go on in the desktop with spreadsheets. I can give you one very simple example of a bank which discovered that its trading in minor currencies was completely governed by a spreadsheet which had been built by an intern, summer intern. And was in fact installed not in the data center on a scalable server, but on the admin assistant's desktop machine, because the intern didn't know how to deploy the application properly. But he told all the traders about it, and they were happily using this spreadsheet. And then its performance started to drop off, and in fact, IT only discovered about it because people complained about the performance. And it turned out that every time the admin did something, like send a fax, or probably more likely watch a video on YouTube, it sucked up all the bandwidth for this application, and nobody could get the trading information that they needed, because an IT didn't have any insight or oversight of that process. And I won't tell you who the bank is, but you know, these things actually happen. I can tell you a worse story about a bank, but actually, yeah, this one's quite funny, because they went through a process. They started with Lotus 1, 2, 3, and then they transferred to Excel, and then they decided to build an application, an actual properly coded application. And this migration from Lotus 1, somewhere in the course of this migration from Lotus 1, 2, 3 to Excel, and then finally into building a proper application. Again, they used mostly summer interns and people like this to do these menial tasks. They had a calculation which was to look at the credit that somebody had in their account at the end of the month, and then, or their balance for a trading account, and then make some estimates of how much trading credit they would need for the following month, which was great calculation. But somewhere in the midst of translating between these different spreadsheet languages and then finally C#, somebody got the word round mixed up with the abbreviation RAND, and they were actually calculating your trading credit based on using your closing balance as the seed of a random number. And the funny thing was, when they fixed it, all the traders complained that somehow this system wasn't working properly at the end of it. So, you know, we have these horrific stories of what can happen when these unmanaged systems are let loose in the world. Now, in the middle, there are different things. We start solving some of these problems with shared spreadsheets. You know, Excel services is a way of providing Excel as a service on SharePoint, such that you don't have to give the spreadsheet to people. You can give them a report based on the spreadsheet, and that can be very effective. Similarly, you can look at departmental data marts, which often live downstream of the enterprise data warehouse in a department, providing a much more focused departmental view. Because one of the problems of the big data warehouse is it doesn't represent exactly what I need to see in the advertising department. It might be good for marketing, but it's not exactly what I need for running my advertising campaign, that sort of thing. Departmental data mart can solve that. Master data is probably the ultimate way of ensuring that IT are delivering a single view of the truth to any application which needs it. In other words, it can be consumed by operational applications, by analytic applications, by spreadsheets, by databases, by data warehouses. But it's a big project to do master data. We have a new product, Master Data Services, in 2008 R2, which can handle some of that. Data quality is going to be coming as part of the core Microsoft stack in SQL Server 11 and the next version of SQL Server next year. Data quality is sometimes called the first among equals of technologies for data governance, because ultimately it comes down to this problem I was saying about data quality as being the definition of fitness for purpose. Data quality technologies are how you ensure that all that diverse data in your system is fit for the purpose that it's going to be used for. What happened there? Okay, I seem to have a bicycle in the middle of this. That seems a little bit random, but I know why. It's just there's one slide missing, because what I was going to talk about was Excel. And the reason I talk about Excel is because I always say that Excel is as familiar as a bicycle. But I seem to have a hidden slide somewhere which had a nice picture of Excel. However, maybe that will come back. Anyway, Excel, good friends, is familiar as a bicycle. And what do you want to do as soon as you find something that's exciting and new and useful? Well, the next thing you want to do is share it with someone. And that's fine in the Excel world. I can share it. I borrowed a USB stick from somebody earlier in order to put my presentation on here. That's what we do with Excel. Hey, I've got a presentation here. I've got an Excel workbook. Let me give you an Excel workbook. I'll give you an example of this within Microsoft. We have the HR system in Microsoft, handles our human resources. At this time of year, it's just coming up to annual review. So people like me who are managers, we're doing annual reviews for all our staff. And I use this HR system quite effectively because it allows us to do things like look at their vacations and look at their salaries and look at their promotions and so on. And we can roll over their vacations to the following year. Now, my team worked really hard on 2008 R2 that we shipped earlier this year. They worked every weekend. They worked nights and all the way into early summer, into late spring, early summer in the Northern Hemisphere. It was really tough for them. And I say they missed many weekends with their families. But we shipped the product, and at the end of that, I say, guys, you've just missed about 10 weekends and about 20 nights fixing bugs. Take an extra day off to make up for it. And when I do that in the system, I cannot do that in the HR system. And do you know why? Because the HR system, first of all, has to comply with every law in the United States around employment, every law of Washington State, every law of the federal system in the United States, every individual's contract. The last thing they can do is give a manager read-write access to that. All I can do is read it. I can't change people's vacation hours and so on as a manager. So I need to build this system, and with my generosity, I mean, I need to track what's happening because these people could go crazy and take it any time. So I build an Excel spreadsheet. When I build an Excel spreadsheet, I do this. I share it with other people and say, hey, TK Anand, you're a manager. This is a great way of doing it. And then next thing you know, he shares it with more people. And the system that was okay when it was a little spreadsheet that I was using suddenly becomes chaotic when it's organized and when I try to share it with more and more people. Now, the thing that drives that pattern from shared, from spreadsheets to shared spreadsheets to data marts to data warehouses is actually collaboration around how do I share it in an effective and economical way. And the way we do that is by collaboration. This is a collaboration curve that takes you from IT oversight and organizational alignment coming together. This is actually why SharePoint is so critical to our BI story. SharePoint is our collaboration platform. So if business intelligence is about decision making and business intelligence is about data, it's also about collaborating around these results. And there's different ways, we have different views of collaborating. The IT department say we build a train and it's highly efficient and it runs effectively and with great performance and everybody gets in the train and they've all got their seat and everything works perfectly. And business users say, we just need to get there no matter what happens. And it doesn't really matter, how structured that system is. We just need to solve our problems. And the problem is that business users have been told, solve your business problems, but solve them using this standardized technology. They've been told, do it, but don't do it at the same time. If you don't have the data, what are you going to do? So business users have been told, stop, don't stop. IT, on the other hand, they don't know if they're leading or following. And yes, strange things can happen if you don't know if you're leading or following. Because IT, are we following the business users and just trying to clean up after them and trying to sanitize this? Or is our role actually to proactively provision the data and decision-making systems and try and keep ahead of the business users? But how do we ever do that? And so you end up with this situation of business and IT continually in this tension. And the analytics that we're trying to introduce in 2008 R2 is we're trying to introduce this area that we call self-service business intelligence. Now, self-service business intelligence, the heart of it is Excel. That is absolutely critical. Excel, as I say, is, and I think this is actually where I had the slide, it's as familiar as a bicycle. Excel in this version, this is like 1987 or something, it shows the sales of compact disc cleaners in 1987. But you recognize this. This is Excel. Everybody knows Excel. You can recognize the rows and columns and the formulas, and you could use this if I sat you down at it. I was at a BI conference last year. I was on a panel discussing business intelligence tool sets. There was an audience, probably about half this size, and we asked them at one point in the panel discussion, how many business intelligence tools do you have in your enterprise? And kind of hands started to go up, and there was a guy at the back who said 29. 29 business intelligence tools. And we, yeah, okay. And we kind of ignored him and looked for somebody more sensible and asked them, and they said, well, yeah, we've got 4 or 5 probably. We've got some business objects, and we use that a lot. And that was him fine. And the guy at the back said, 29. I've got 29. And we kind of ignored him even more and asked somebody else. And they said, well, we have 9 or 10 because we've grown by acquisition. We were a business object shop, but we acquired a company that was running TIBCO Spotfire. And actually then we decided we were going to consolidate on Microsoft Stack, but we're still using business objects in the back end. So we've got like 9 or 10 different applications. The guy at the back's getting frantic. He says, 29. And at this point, we totally try and wrap it up, and I asked the lady at the front, how many do you have? And she's really embarrassed, and she said, well, we just use Excel for everything. And the room is kind of quiet, and the guy at the back says, 30. I've got 30. Excel is the application that everybody forgets about. It's the one that, I'd say 99% of business decisions have Excel as part of the process somewhere. The familiarity is actually really important, but with that familiarity comes some risks. I was telling you about the intern writing a trading application in Excel. People write applications in Excel, and you wonder why on earth they've chosen Excel to do this strangely vertical thing. But the truth is, it's easy. We all understand it. It's very familiar. People do stuff with Excel that you just wouldn't believe. And again, they do it because it's familiar, because it's easy for them to build that. And so, our challenge was, okay, how are we going to make Excel better? The first thing to got to know it is we can do this. Microsoft understands Excel. We own Excel, and we also understand the Excel user. So we are the people who can do this more than anyone else. So we introduced this product called Power Pivot. And Power Pivot has some real challenges. But the first thing that we had to do in Power Pivot was get beyond Excel's limits. Excel has a 1 million row limit for handling data. And that sounds a lot if you're in a small business. But if you're in an online business, even a small online business, to be honest, then 1 million rows, 1 million transactions isn't really going to cut it for anyone. And most businesses have more than 1 million rows of data, even in their simplest systems these days. So, 1 million rows just isn't enough. So the first thing we had to do was make Excel more scalable and take it beyond those limits to something that was still familiar, but at the same time could go to much higher scale. Now, if you're going to do that, and if anybody's tried to use, say, more than 100,000 rows in Excel, you'll realize that because it calculates every cell individually, performance isn't great when you get above, say, 100,000, 200,000 rows. So the next thing we had to worry about was speed. Can we make Excel faster? Hopefully more reliable than this, but nevertheless, speed was of the essence as well. It had to be fast. And then it also had to make it more flexible, more interactive, have more business intelligence capabilities than we'd ever seen before in Excel. And then the third thing is we wanted to make it easy for people to acquire. So what we did was we took Power Pivot, and how many of you have seen Power Pivot? Okay, that looks like about half of you. So I'm not going to go deep into this because we also have another session later where I can show more about Power Pivot. But I'm going to show you a couple of things. The first thing I want to show is, first of all, that this is an add-in to Excel. It's an add-in to Excel 2010, and it's a free add-in. Talk about making it easily available. This doesn't cost you anything. If you've got Excel 2010, you can download this. Also, Excel 2010 installs side by side with Excel 2007, 2003 if you need that. Power Pivot installs into that environment, and in this example, we've got movies, and we always like to show this example because it shows us data brought in from a data warehouse, but it also shows you something of the volume that we can handle. There's 101 million rows here, and it's running on this laptop machine that I have here, this 3 gigabyte laptop machine. And not only is it running 101 million rows in memory right now, it's highly performant. If I want to sort this, the sorting is effectively instantaneous. If I want to filter it, which is in effect querying the data set in memory, then the results of that are in effect instantaneous. Now, we need that for two reasons. First of all, like I said, Excel doesn't perform great with 1 million rows of data, and we were going to use 100 million rows. It better be fast. But there's another reason, which is our audience. Now, we're friends here, so I can tell you, and you won't share it with anyone, that our target audience for Power Pivot, we like to call them people who can spell Excel, but they can't spell BI. And what we mean by that is nothing about their intelligence. We just mean they don't know what BI is. They've never heard of it. They don't understand how to join tables. They don't understand queries and relationships. They don't understand time intelligence and structures and so on. But they do understand Excel. And these people tend to do stuff until it just looks right. And once it looks right, they're kind of happy with it. And the problem with that is you can do things. If I just go through here to this workbook and grab, for example, these are currency codes for the different transactions. If I just take that and paste it into the Power Pivot environment, now, by the way, I have data not only from my data warehouse that provided me with millions of rows of data, I now have 5 rows of data that I've just pasted. If I want to analyze that, we use pivot tables, that's the name Power Pivot. If I want to say something like, well, show me the purchases, That's going to be hopefully 101 million rows. Yeah, there we go, 101 million rows. And I could say, well, now I want to analyze that by the data I just pasted in. So show me that, for example, by the currency code. And now I get the answer. And I just do stuff until it looks right. And I've got to tell you, that doesn't look right. I don't have to be a banker to know that that doesn't look right. Don't even have to be an American banker to realize it doesn't look right. Anybody know what's wrong? Wow, lots of people shouting out there. Yeah, I mean, there's no relationship between the tables. I just said, show me currency codes and show me purchases. It didn't say how they were joined. Fortunately, Power Pivot knows that as well and says a relationship may be needed, which is technical rather than personal advice in this session. But although those who shouted out may need to get out more, but there you go. I can say create the relationship, and we'll go in and we'll look at the metadata of the tables. We'll look at the data within the tables. We're trying to find an unambiguous join between these tables. In other words, one perfect join that would bring them both together. It's a demo, so we find it. And now the data looks right. And so the business user, first of all, they've got something that looks right, so they're happy. They've learned something, that the relationships are important, and the next time they see that result, they'll probably create the relationship manually. By the way, if we didn't discover it, you'd still be able to create the relationship. You'd just be able to create it manually rather than using Power Pivot automatically to do it. So we try and make it easier. We try and give that kind of power and flexibility to the user. Now, the environment here that we work in then, let's think of this, and I'm going to wrap up with my kind of last set of diagrams here. I like to think of this as providing software along these two axes. First of all, the vertical axis is how much does the software help you solve your problem? Well, how proactive is it as opposed to passive? And then the hypothesis axis is a little bit difficult to explain, but a strong hypothesis is I know exactly what I want to show you. And a weak hypothesis is I really don't know when I sit down at my computer what I'm looking for. Okay? So to give you an example, the easiest way to describe it would be to say this. Look, reporting. I'm building a report. I know I want to show you sales by customer, by district, by every month. That's a very clear hypothesis. All the software has to do, well, it's a big all, but all the software has to do is help me format that nicely, create a good-looking report, schedule it, and so on. It's very passive. The software isn't helping me solve my business problem. It's just helping me present it nicely. I still have to do all the work to have the strong hypothesis. Ad hoc reporting, yeah, it can be a bit weaker. I can add a bit. I can do a bit more changes. I can give it to a business user, and they can change it a little bit themselves. But fundamentally, the software still isn't providing that much in terms of problem solving. OLAP, on the other hand, is very different. OLAP is primarily exploratory. Whether you're using it with a specialized tool or whether you're using it just with Excel, OLAP is about exploration. It's about the situation where when I answer a question, I have another question. So, for example, I can look at, I'm from Seattle, so they look at, they're trying to analyze my store account at Safeway, and they say, this guy seems to buy a lot of beer and shampoo. How are these things related? And, they say, well, the weather's warm, sales of beer are up, but sales of shampoo are up too. Last month, however, sales of shampoo were up and sales of beer were down. His parents were visiting. And they can analyze these different things. But every time I ask a question, it leads me to another set of hypotheses. The primary job of the software is to enable me to explore that. It's not passive about it, though. It provides me with the structured hierarchies and so on that have been built in by the IT team so that I see how I can explore the software. The spreadsheet also helps me if I don't have a strong hypothesis, but it really doesn't do as much as the OLAP application in helping me to solve it, because really it just says, here's a workspace you can do stuff in. We're not providing you with structured input. Data mining, on the other hand, what I showed you earlier, where we went out and we discovered that using a neural network, how to predict certain patterns about house owners. Data mining, you can have a fairly weak hypothesis. Data mining is doing the proactive thing of finding the patterns and solving the problems. So data mining acts where you have very weak hypothesis and provides you with really proactive software to solve that. Search is actually a kind of weird example of software where your hypothesis may be very weak and software doesn't help you very much. If you Bing for something, Bing will provide you with a ton of results, but it's really up to you to know what search terms to use and what you're going to choose to review afterwards. Monitoring and analytics are interesting because monitoring is pretty strong. It provides you with the KPIs. It provides you with these indicators. Well, somebody has to write those, and they show you the most aggregated view of your business you could possibly imagine. Every transaction in your company is reduced to something which is either red or green. That's a pretty high degree of data aggregation there. But so the hypothesis is very strong. And the software, however, does provide you with insight, because the next thing you can do is, if you don't understand it, is drill down to the analytic stage and use things like the decomposition tree to break that down and understand a little bit of how that number was made up. Performance point monitoring and analytics, then, we kind of bring that area together into one and say that's one set of technologies. Something such as Report Builder, which is about reporting and ad hoc reporting, it really covers that space even more. If I was to have reporting services, it would be right down in the bottom right-hand corner if I was using, say, Report Designer in Business Intelligence Design Studio. And the data mining technology, especially the add-ins for Excel, they're right on the right-hand side there, where you've got very weak hypotheses that you need to explore. Power Pivot, our new technology, is really built around this whole central area of exploration, both this very ad hoc type of exploration, but also exploration driven by the business user. Now, looking at the three things that we've talked about today, decision-making, governance, and these analytic technologies, you really, when you look at your business, end up thinking about three things. What are my decision-making processes? How is my data governed? And how am I going to analyze it in the best possible way? How am I going to give the right tools to people to do this work? We have many other sessions in the BI track and in the data track which cover this. And I've got a session tomorrow, and in fact, in the session tomorrow, I'm going to be giving away an Xbox Elite, so you definitely want to come along to that one, where I'll be talking about how we do that in this SQL Server 2000 Data R2 release in more detail. We'll also be talking a little bit about the roadmap, but there's something I want to tell you about the roadmap. Not technically, but conceptually. We started, with the guys back in 1914 wondering, about how they solved their problems with the old data centers and the old desktop environment. I'm going to tell you something that you might not hear in any other technology presentation. The future actually doesn't change that much. It hasn't changed in 196 years. It's not going to change now. You're still going to have people trying to solve business problems on the desktop. You're probably still going to have IT departments struggling with it. Everything comes back in cycles. Have a look at these guys in their splendid blue puffy pants there. And, even that came back at one time. And you think of that central IT team driving the set of calculations. They were there back in 1914. They were there in the 1960s. They were there today in the modern offices in their cubicles, still driving that central version of the truth for the business. The desktop environment, what do users do there? They used pivot tables back in 1914. This is a 1915 pivot table. Nowadays it looks fancier, but it's still trying to give business people the same insights as they needed to be effective back then. The world of the data center has moved on through different generations. The world of the desktop has moved on, but it's fundamentally still the same problem. We haven't really solved it. And when I say we haven't solved it, I really want to get across that technology doesn't have a magic solution for this. This is about your business. This is how businesses run. Business intelligence makes them better by giving you the right information at the right time to make the right decision. But I don't want anyone to go away from here thinking that any of the technologies that we have or anyone else has somehow magically change this environment. It's about how you work in the technology environment and, importantly, how you work in the business environment to solve decision-making problems. That's what I call the title of this presentation, Decisions, Decisions, Decisions. It's about decisions, and business decisions fundamentally have not changed that much over the years. So with that, I want to encourage you to go to as many sessions as you can in the data track. I really hope you come to my session tomorrow where I'm talking, the 301 session, where I'm talking more about the technologies we have in R2. But I hope this has given you some food for thought. And thank you very much for your time this morning. Thank you. I don't know if I'm going to get thrown out of the room, but if anybody has any questions, I can kind of ask until I can answer questions until I'm thrown out. And if nobody has questions, that's also fine by me too, because my throat's going.